So in this video, we'll take a look at natural logarithms and logarithms of all other bases. Now, a natural logarithm is a logarithm with a base e. E is a mathematical constant, which is Euler's number, somewhat like pi, if you know pi already. The approximate value of e, which is an irrational number, is 2.718281828, and so on, forever. Your scientific calculator is programmed for natural logarithms. If you take a look at the log button on your calculator, beside it you will see a button that is the ln button, ln. And I'm saying beside because they're generally beside, but take a look at your calculator for the ln button. This natural logarithm is known as a ln, pronounced ln. So, when you see ln of a number, that means log base e. Try some of these on your calculator. Find the natural logarithm of the following values. You will find this number by punching in ln 2.7183 and see what the number is. You will see that this number is basically 1. I had to round the 2.7183. I would like to put in the ln, or the value of e, but basically the ln of e is equal to 1. That's because e to the power of 1 is equal to e. Try some other ones here, and as you're working on your calculator, I will fill in the correct values also. Round to about 3 or 4 decimal places. Okay, so you're pressing ln on your calculator and punching in the number that we are finding the natural logarithm of. What this means is, for example, in the ln 500, e to the power of 6.2146 is equal to 500. And of course that's approximate because I had to round this value here. So when you try to reverse it, it won't be exact, but it's very close. The more decimal places you keep in this value, the closer you'll get to 500 when you try reversing it. Just like we saw an anti-logarithm with common logarithms, there is also a natural anti-logarithm. The natural refers to the base e, and the anti-logarithm refers to the function of raising e to a power. So take a look at your ln button on your calculator, and you will see probably the second function of it is e to the x. That button is for finding the natural anti-logarithm of a value. You are finding the value of e raised to a logarithm. So use your calculator and try raising e to these powers 3, 5, and 1.2. I will also work along with you and fill them in. e to the power 5 sometimes I have to round that last number. Okay, so hopefully you work along and you are seeing the same values by using that second function of e on your calculator. Now, we have examined how to find logarithms and anti-logarithms of base e and base 10. What about all other logarithm bases? Because the calculator buttons are programmed for base 10 and base e. But what about all other bases? So here's a formula that we can use for all other bases if you don't have a function on your calculator that will do other bases. Log base b of x, where b is any base that's a positive value. We do this by finding the ratio of the log of x over the log of b. And notice that those two logs here and here don't have bases. So that's base 10. These are common logarithms. We can also do the same ratio with the natural logarithm button, as long as we are consistent. So for example, in this one here, find log base 5 of 125. Now remember, if we switch this to an exponential function, we are asking what is 5 raised to equal 125. So we want to know the exponent on 5 that equals 125. Well, anyway, log base 5 of 125 can be found using the log key by finding the log of the argument and dividing by the log of the base. And you'll see this is equal to 3. You can also use the ln key, ln 125 divided by ln 5. Try some for yourself. And on the last one, just do it over here. I'm going to use the ln key instead. So, ln of 147 divided by the ln of 9. 2.2712. We'll take it that far. There is more, but we'll round it there. This means, just translating, that 9 to the power of 2.2712 is equal to 147. Now remember, this is rounded. It's not going to be the exact, but let's just check it. 9 to the power of 2.2712. And you'll see we get 146.985. Now that difference is only because I rounded here. The more decimal places I keep, the more it would be exact when we try reversing the operation. So that's how we find logarithms using the calculator. Check your calculator. You might have a function that looks something like log base b of x or log base x of y, but it might look like that anyway and have the ability to put in different bases. If not, at least you have these formulas that you can use. Thanks for watching. Bye.